Take a moment to read the question. So two pairs of straight lines, x squared minus 7x plus 6 equals 0 and y squared minus 14y plus 40 equals 0 intersect to form a rectangle. The diagonals of this rectangle meet at the point W, and a circle with the center at W and tangents as the second pair of lines intersects the first pair of lines at the points P, Q, R and S. And we have to find out the area of the rectangle PQRS. How do we do this question? Well, let us look at the first pair. So we have x squared minus 7x plus 6 equals 0. We can factor it like this. So we find that we have two vertical lines, x equals 1 and x equals 6. From the second pair, on factoring we get this, which means we have two horizontal lines, y equals 4 and y equals 10. We can now draw a diagram like this. So the circle's center is the point W, and we have joined W with P, and that's the radius of the circle. Also, we have dropped a perpendicular from W to the line PQ, and we are calling it M. From the diagram, it is very clear that the coordinates of the center would be given by the midpoint formula. So that simplifies to 7 by 2, comma 7. Now the length QR must be equal to 6 minus 1, and that's equal to 5. The radius of the circle must be equal to 10 minus 4 divided by 2, and that's equal to 3. Now PW is also the radius of the circle, so that too must be equal to 3. Now MW is half the length of QR, so that's equal to 5 by 2. Now we can apply the Pythagorean theorem and say that PM would be equal to the square root of PW squared minus MW squared, and that turns out to be this number, which is root of 11 divided by 2. Now PQ is twice of PM, and that's equal to the square root of 11. The area of rectangle PQRS must be QR times PQ, so that should be 5 times root of 11. So the correct answer is option B.